All right, today we're going to be looking at how to write an equation for a linear graph that is parallel to another line. Okay, so here we have the problem. Write an equation in slope-intercept form for the line that passes through this point and is parallel to the graph of y equals 2x minus 4. Okay, now the first thing that's given to us is that we want to write an equation in slope-intercept form. And so to write that equation, let's see, we're going to need y equals mx plus b, since that's slope-intercept form. All right, and so now that we have that, we need the slope and we need the y-intercept. Okay, so to get the slope and the y-intercept, let's go ahead and figure it out. We know that the slope is going to have to be parallel to this graph. So how do we make an equation that is parallel? Well, hopefully you remember that parallel means same slope. So, since the slope of this graph, which is in y equals mx plus b, is 2, that means that the slope of my new equation needs to be 2. So that means I need a slope of 2. Now, from here, there's actually two ways that you can do this. You can plug it straight into the y equals mx plus b. We can say y equals 2x plus b, which means we now need to solve for the y-intercept. Okay, now to do that, we're going to take the point. Now remember, this right here is the y-intercept of the old line. We are writing an equation for a new line that goes through this point. And so when we do that, we're going to go ahead and we'll put in this point, this x and y, for the x and y here temporarily. And so it'll be 5 equals 2 times negative 3 plus b. So that would be 5 equals negative 6 plus b. Add 6 to both sides. And then I've got 11 equals b. And so then I can put it straight in. Y equals, now remember I want the y and the x there. That's how I get the equation relating x and y. M is of course the slope, which was 2, x plus b, which was 11. Okay, now there's another way to do this. The slope is still necessary. You have to understand that the parallel slope is the same. But since we have a slope and a point, you could have done it this other way. Okay, so I'm actually going to make a line down the middle, and we're going to do way number 2. Yes, way number 2. All right, so let's go ahead and do that. So we could have put it in point slope, and you may remember y minus y1 equals m times x minus x1. All right, so we can put in the slope, and we can put in the point that's given to us. So y minus 5 equals the slope, which we know has to be 2, times x minus x1. Okay. Now, of course, this is an acceptable equation, but it is not in slope-intercept form. And so from here, I can rearrange it. So we can say y minus 5 equals 2 times x plus 3. Okay. We'll distribute the 2. Y minus 5 equals 2x plus 6. We add the 5 to both sides. And ta-da! We've got y equals 2x plus 11, which is the same thing as we had over there. Isn't that great? The answer to that question is yes, that's great. All right, so there you go. There's an equation in slope-intercept form. We got the slope from the fact that it was parallel. Okay, this was the old line. We wanted one that was parallel to that. A parallel line will look the same. It'll have the same slope, but it will have a different y-intercept. And so we didn't need the y-intercept here. We did need the slope. That's the slope that we used in both of our equations. In one, we did the temporary substitution of the point in slope-intercept form. The other, we used point-slope form and then rearranged it. They both gave us the same thing. Good luck on that on your homework.